All right, so welcome back, students. We're going to continue this discussion of movement of heat. In the previous video, we kind of left it off here. We had talked about how a flame could accelerate particles immediately above it, and those particles, because of the increased kinetic energy, would then collide with a container holding another substance, maybe a gas, maybe a liquid, and the molecules above the flame would then collide with that container wall, cause the area of impact to increase its kinetic energy, thereby increasing temperature, which then could be transferred to a particle on the inside wall of the container that would allow it to absorb some of that energy, thermal, and then thereby increasing its kinetic energy. And so throughout the whole process here, what we see is that there is this huge transfer of energy from here, let's say here at the point of combustion, because that's what's going on here at A. Let's say here combustion. So if we're combusting a gas, whatever gas that is, because we do have a flame, or if we're burning a piece of wood or some other material, there is a combustion going on here. Okay, so let's look at it from the standpoint that we're combusting a gas like methane or some similar type material. And then as it goes through, the highest concentration of heat here is going to be high. And as you move through, the lowest concentration of heat is going to be here at the top. So the heat concentration here is going to be low. And so what happens overall, though, is that you're going to have a transfer from one substance to the next, and it definitely travels this heat concentration gradient that essentially goes from high to low the way we had discussed in this manner here. So the idea behind this, though, is that we need to make sure that we understand that this particular transfer of energy is only going to continue to do so as long as there is a concentration gradient. So as long as you have one substance or one side of the reaction or reactant with a higher temperature than, say, another one in the reaction, or as long as you have one body of a material that is at a higher temperature than another one when they come into contact, that transfer or that movement of heat will follow this overall high to low mechanism that we have up top. Now, when it actually reaches a point where the concentration of heat is equitable, so let's say if we do it this way, once the heat, let's say that from sample A or here, is approximately equal to the concentration of heat at sample B, we already know what this is. Think about it in terms of what we were doing with K expressions. We now know that this is going to fastly approach 1. And so this particular section here, just like in the other sections, this is a state of equilibrium relative to the heat. And so we usually say that this is going to be a heat equilibrium, or rather what we have here is thermal equilibrium. And so I'll just put this over here on the side, put it in green here, so it stands out. But when you have the energy or the thermal energy being transferred from, say, a body of A to a body B, and that temperature gradient decreases because you're transferring heat from one to the other, say from A having higher to B lower, as long as that energy has a gradient, we are going to transfer from A to B, but eventually B is going to increase in temperature because it's gaining that temperature that it's gaining from A, and eventually that temperature is going to be very close to each other, and eventually it'll be the same. That point where they are the same, this is known as thermal equilibrium, and this is a state where there is no more heat flow. Okay, so heat does not flow anymore at this section here, and so we got to make sure that we identify that. So no more heat flow. So this is a very important thing to kind of wrap your head around as we consider this movement of heat. Okay, and so just keep that in mind, that this is all the same thing we've been talking for a long time now in terms of concentration. So if concentration always goes from high to low, and when the concentration is of the products is going to be relative the same as the concentration of reactants, in this case product of heat generated or reactant of heat input, when those concentrations of that particular variable is the same, then we have reached a state of thermal equilibrium. And so on this here, then we now do need to move forward and talk about how does this work with regards to substance A and substance B, how do you tell them apart? And so in the next couple of videos, we'll explore that, and we'll talk about concepts such as system and surroundings to help us there. And we'll also kind of do a quick little review of what endothermic and exothermic means as we move forward to try to establish this idea of a thermochemical equilibrium, or that thermochemical equation. So with that, if you haven't already done so, go ahead and click subscribe. Keep watching, keep learning, and we'll see you in the next one.